Welcome! Today we're going to tackle a concept that sounds super advanced, but is actually as simple as an assembly line. We're talking about composite functions. Let's break it down.
So, first things first, just think of any function as a simple little machine, right? It has one job, you put something in one end, we'll call it x, the machine follows its rule, does its thing, and spits out a new result. That's really all a function is.
Okay, but here's where it gets really cool. What if one machine just isn't enough to get the job done? What happens when you start linking them together, one after another, like a mathematical assembly line?
Well, that idea, that whole concept of one machine's output becoming the input for the next machine in line, that's a composite function. That's the entire game right there.
Now here's how you'll see it written down. This little open circle notation just means composed with. But the part you really need to focus on is this, f of g of x. We say that out loud as f of g of x. And here is the golden rule. You've got to remember this. You always work from the inside out. Start with the function that's closest to the x. Let's trace the path on our assembly line. So your starting material, x, goes into the first machine, the g machine. It gets processed, and out comes a new part, g of x. But we're not done. That part immediately gets put on the conveyor belt and goes straight into our second machine, the f machine. And what comes out at the very end? That's our final product, f of g of x.
All right, enough with the abstract ideas. Let's get our hands dirty and see how this thing actually works with some real numbers. Let's run the line.
Okay, check this out. Our first machine, g, has the rule double the input and subtract 1. The second machine, f, just squares whatever you give it. We want to find f of g of 3. So, remember the rule, inside out. First, the number 3 goes into the g machine. 2 times 3 is 6, minus 1 is 5. Okay, so the g machine outputs a 5. That 5 now becomes the input for the f machine. What does f do? It squares things. 5 squared is 25. And there you have it, our final output.
Now, this probably brings up a pretty important question. On an assembly line, the order of the machines is everything, right? You can't put the doors on a car before you've built the frame. So, does order matter here? If we swap them, do we get the same thing?
Well, the answer is a big, emphatic no. The order is absolutely crucial. Let's take a look. With these two new functions, when we calculate f of g of x on the left, we get this whole expression, negative 4x squared minus 12x minus 8. But now, let's flip the assembly line. Let's do g of f of x. As you can see on the right, we get a totally different result, negative 2x squared plus 5. Not even close, right? So the big takeaway here is that function composition is not commutative. Order is everything.
So, we know order is key. But there's another thing. Every machine has rules about what kind of material it can even handle. You can't put a steel beam into a wood chipper. In math, we call the list of acceptable inputs the domain. And if we ignore it, the whole assembly line can jam.
And really, there are only two safety checks you need to make. Rule number 1, your starting input, x, has to be something the first machine, g of x, can even process. Makes sense. And rule number 2, whatever comes out of that first machine has to be something the second machine, f of x, is designed to handle. If you break either of those rules, the line grinds to a halt.
Let's look at a really good example of this. With our function g, it's pretty obvious that x can't be negative 1, right? Because then you'd be dividing by 0, and the machine breaks. But there's a more subtle problem. What happens if we try to put x equals 0 into the line? The first machine, g of 0, is fine. It spits out the number 1. But when that 1 goes into the second machine, f, we get 1 over 1 minus 1, which is division by 0 again. The second machine gets jammed. So for the entire assembly line to work, we have to respect both restrictions. X cannot be negative 1, and x cannot be 0.
Okay, so we've gotten really good at building the assembly line, but what about taking it apart? This is a skill called decomposition, and it's kind of like being a detective.
So imagine this scenario. You're handed just the final product, this function, h of x. Your job is to figure out what were the two simpler machines, the f and the g, that were chained together to make this more complex one.
You know, the trick is to think about the order of operations. Just like our assembly line, what is the very first thing that happens to x? Well, it has 2 subtracted from it. That's your inside machine. G of x equals x minus 2. Okay, now what happens to that entire result? The whole thing has a square root taken of it. That's your outside machine. F of x equals root x. And just like that, we've reverse engineered the line.
So you might be thinking,
Okay, this is a neat puzzle, but why does this really matter? Why spend all this time building and taking apart these function machines? Well, it turns out this skill is the key that unlocks the door to calculus.
Now, don't get intimidated by this. This thing here is called the difference quotient, and it's one of the most important ideas in all of calculus. But you don't need to understand the whole thing. Just focus your eyes on one little part of it.
This bit, right here, f of x plus h. You see it, don't you? That is a composite function hiding in plain sight. The inside function is x plus h, and that whole thing is being plugged into the outside function, f. Being able to see this structure, to build it and break it down, is not just a party trick. It is absolutely fundamental to understanding how things change, which is what calculus is all about.
Kinda makes you think, doesn't it? Mastering something that looks really complex is almost never about one giant impossible leap. It's about seeing how simple, understandable ideas, like our little function machines, can be linked together step by step to create something powerful and amazing. So what other big ideas out there are really just simple steps combined?